Recall the precise definition of the definite integral. We also recall the notation for the definite integral. Example. Find the exact area under the curves y equals x to the power of 2 on the interval 1, 2. In part 1 we did a similar problem, but much easier than this. But the principle is exactly the same. The width of each rectangle is delta x, which is b minus a over n. In this case it's 2 minus 1 over n, which is 1 over n. We are going to use the representative point as the right endpoint of each of the sub-intervals. And this would make this example much more difficult than the one that we did in part 1. Because now, as you can see, the first right endpoint is 1 plus 1 over n. It's much more complicated than just 1 over n. The second one is 1 plus 2 over n, so forth. The one before the last one is 1 plus n minus 1 over n, and the last one is 1 plus n over n, which is also 2. But in each case, the right endpoint in each of the ith subinterval is xi star, which is 1 plus I over n. We need to find the pattern. And this is definitely the pattern. Now you can see that. Also, the last one, it's 1 plus n over n, which is 2. It's very good to check the pattern by actually expressing the b. In this case, it's 2, using the pattern. So the pattern is 1 plus n over n. And if you get 2, you know that the pattern is right. Now let's write the total area. It is the limit n approaches infinity of 1 over n, because delta x is 1 over n, times the sigma of the fxi stars when I runs from 1 to n. We are going to replace the fxi star by f of xi star is 1 plus I over n. We also know what is the function. The function is x to the power of 2. It means that f of 1 plus I over n is 1 plus I over n to the power of 2. And I get now this one. In order to evaluate the sigma first, I will need first of all to expand 1 plus I over n to the power of 2. Now I see that this sum has actually 3 parts. I also note that the sigma is only related to the I, not to the n. It means that n is like a constant, but only within those brackets that you see. I would like to recall again that the limit is related to n, so you cannot take 1 over n, for example, out of the limit, but you can take it out of the sigma notation. So I'm using linearity, and I get that instead of writing the sigma of 1 plus 2 times I over n plus I to the power of 2 over n to the power of 2, using linearity I get the 3 following sums. From the 1 I get the sum I runs from 1 to n of 1. From 2 I over n I get 2 over n, 2 is a constant, over n is a constant, sigma of I when I runs from 1 to n. And from I to the power of 2 over n to the power of 2, I get 1 over n to the power of 2 times the summation of I to the power of 2 when I runs from 1 to n. I already have expression of n to these two sums. The sums of I is n times n plus 1 over 2, and the sums of I to the power of 2 is n times n plus 1 times 2n plus 1 over 6. it means that I can replace this by the expression of the n. And this is wonderful because I got rid of all the sigma now. I don't have i's anymore. And this is just a big expression of n. And I need just now to take the limit of n approaches to infinity of this one. After, obviously, I'm going to do some algebra here. So I can first of all cancel this with this. Here I can cancel one of the exponent with n. And I get this one. This is much better than before. And obviously I'm going also to distribute the 1 over n. So I'm cancelling, distributing the 1 over n, and I get limit n approaches to infinity of 1 plus n plus 1 over n plus expand the n plus 1 times 2n plus 1, and we get 2n to the power of 2 plus 3n plus 1 over 6 n to the power of 2. One of the n's is from the 1 over n before the bracket, and the other one is because I have 1 over n there. Now I need to take the limits, and the limits is just, for the first one is 1, because limit n approaching to infinity of 1 is 1. The limit of n plus 1 over n, when n approaches infinity, is 1. And the last limit is 2 over 6, which is 1 over 3. And I get 7 over 3. This is the total area under the curve y equals x to the power of 2 on the interval 1, 2. I conclude that the definite integral of x to the power of 2 dx between 1 and 2 equals 7/3. Example. Express the limit of the Riemann sum of the function f(x) equals 1 plus x to the power of 2 on the interval 0, 1, given by the limit 1 over n times the summation of f(xi star I runs for 1 to n as definite integral. The function is 1 plus x to the power of 2, and a is 0 and b is 1. Delta x is b minus a over n, which is 1 minus 0 over n, which is 1 over n. So it's clear that the limit that it's written in the example is actually the limit n approaches infinity of 1 over n, which is the delta x, times the sigma of fx I star I runs for 1 to n. And I know what the function is. I can rewrite it like this. And this is also this, because 1 over n is delta x. And I get the integral of the function, which is 1 plus x to the power of 2, times delta x, which is now going to be dx when n approaches infinity. And because the interval is 0, 1, the limits of the integrals are going to be the lower one is 0 and the upper limit is 1. Example. Express the area under the curve y equals x plus 2e to the x on the interval 3, 5 as a Riemann sum and as definite integral. As a Riemann sum, first of all we have to find delta x, which is the difference between b and a over n, and we get 5 minus 3 over n, which equals to 2 over n. And here is the setup. This is the limit n approaches to infinity of 2 over n, which is delta x, times the sigma when I runs from 1 to n of f of all those xi stars. Because I have the function to be x plus 2e to the x, I will replace the f of x sub I star by x sub I star plus 2 times e to the power of x sub I star. Now we want to see the division on the interval 3 and 5. Here's the subdivision. The difference between each consecutive point has to be delta x, which is 2 over n. So if we start with 3, then the next point is going to be 3 plus 1 time 2 over n. And the point after that is going to be 3 plus 2 times 2 over n. And the one before the last one is going to be 3 plus n minus 1 times 2 over n. And the last one is obviously b, which is 5. I'm going to choose as my representative here, or if you want, as xi star, to be the endpoints from the right. So this is the first one, this is the second, and so forth. This is the one before the last one, and this is the last one. Now I need to find the rule here and the pattern because I need to express those as something that has to do with I. I see here the pattern, and I can check in the last one. If the pattern is 3 plus I times 2 over n, then in the last one I equals n. And indeed, 3 plus n times 2 over n is 3 plus 2, which is 5. It means that x sub I star is actually 3 plus I times 2 over n. I can also write this as 3 plus 2 over n times I. It means that now I'm going to replace all the x sub I stars with this one. Now I'm just going to substitute this into the sigma notation. As definite integral. Limits of integration are 3 for the lower and 5 for the upper, and the integrand is just x plus 2e to the x, and we get this.